So we will continue our session on coordinate geometry. This is your third session. So if you remember, so far we have completed section formula, right? Distance formula. We have seen midpoint formula. Then we have seen area of the triangle. Then we have seen conditions of collinearity. Okay. Then we have seen area of any polygon, right? After that, we started with, in the second session, the centers of triangle, and in fact we need to continue the session here. See, we have seen circumcenter, no, not circumcenter, we have seen centroid, right? So we started off with centroid. Okay, then you understood centroid as x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. Okay, then after that we have seen incenter. Okay, so incenter as ax1 plus bx2 plus cx3 divided by a plus b plus c. Then ay1 plus by2 plus cy3 divided by a plus b plus c, right? We have understood centroid and incenter and their coordinates. Okay. After that, we have seen excenter. Excenter. So if you ask me what is centroid, centroid is nothing but the line segment which is joining the vertex and the median, right? The median, right? The center of the opposite side. That is what the median, right? So centroid is nothing but the intersection of the medians. Incenter is nothing but the intersection of the not cutting. That means the sides of the triangle is acting as the tangents to the circle. Then such circle is called as incircle. Center of that circle is called as the incenter. Radius of that circle is called as the radius. And we have seen how to find the radius and everything in the previous session, right? Then we have seen excenter. Excenter is the center that you got. Okay, when you are drawing a circle, it touches one of the sides of the triangle and the produced sides of the other two sides of the triangle, right? That's what excenter. We will get x circle. We understood how to find the radius of the x circle. And what is in fact excenter? You drop this internal angle bisector, then two external angle bisector, the intersection of two external angle bisector, and the internal angle bisector is what your excenter. Okay, and that we have understood. Corresponding to each angle you have each excenter. Okay, so opposite to A you will get one, opposite to B you will get one, opposite to C also you will get one. And we have seen the corresponding XY coordinates, right? So we have used the same formula that we used in case of incenter. Just the change that if you need to find the opposite, okay, excenter opposite to A, put A minus. If you need to find the excenter opposite to B, put B minus in the equation of incenter. If you need to find the excenter opposite to C, what you need to do in the equation of incenter that you have already learned, put C as negative. Okay, that's it, you'll get the answer. Now here in this session, we need to discuss the other types. So we have so far covered three centers: centroid, incenter and excenter. Now we need to discuss about orthocenter and circumcenter. Okay, and after that we'll solve some of the questions, right? So what is orthocenter? Let me start off with orthocenter. So orthocenter. So you have a triangle, okay? You drop this, okay, like this and like this. Now here, this intersection is your orthocenter, right? Now you may think that what is the difference between centroid and orthocenter then? I have dropped one from vertex in the previous case also, in this case also. Now that you will better understand if I say that in case of centroid, what you are dropping, that was the median, right? That means this two will be divided equally in case of centroid, and these two will be divided equally, and this two will also be divided equally. But here that is not the case. Here if I draw this diagram in slightly different way, you will understand it better. See, if I draw this triangle like this, then you understand it better. I am dropping it here. Okay, so you can clearly see this and this are not equal. These two are not equal, right? So the point is, this is perpendicular. Okay, so the line segment which is joining the vertex and the opposite side and being perpendicular. So this is what we call as the altitude. Okay, so here this triangle, this is perpendicular, and this is perpendicular. The sides are not equal. The sides will come equal in special case, we'll discuss that. Okay, but here keep in mind this may not be equal. Okay, so the difference is, see, in the previous case when you are dropping, okay, in this diagram itself you can understand, here itself you can understand. So this case is altitude, that is, this is 90 degree, right? 90 degree with the opposite side. In the previous case, when it comes to centroid, what I was doing is, I wanted a point in this side which is dividing equally. So my median goes like this. Now you got the difference, right? So this line segment, this is first line segment that is related to centroid, that is a median, because this is dividing equally. Two sides are divided equally, but here two sides are not divided equally, you just dropped a perpendicular. So this is called a median and this is what your altitude. Okay, now what is your orthocenter? Orthocenter is nothing but, okay, you drop the altitudes, okay, this is nothing but the intersection of altitudes. So this is your orthocenter. What is the difference between centroid and orthocenter? Centroid is the intersection of median, and if intersection of median means this line, okay, so this is dividing the opposite side equally, but here that is not happening. Here this is perpendicular. There it was not necessarily perpendicular. It can be perpendicular also, okay, but here it is always perpendicular but not dividing equally. So I can't say these two sides are equal. I can't say that. If it is altitude, okay, if it is median, definitely it has to be equal. I can't say whether it is perpendicular or not. That is the difference, okay. So this is what your orthocenter. I hope you understood this. Now we have seen in case of centroid, the median divides the opposite side in such ratio. In case of incenter also, we have seen the angle bisector, the internal angle bisector is dividing the opposite side in some ratio. Here also we need to see the altitude. So this is the altitude, okay, let me mark it as A, B, C. So A, we know the coordinate x1, y1, okay, B is x2, y2, and C is x3, y3, okay. So you know the coordinates and you can mark this as D, E, F. Now if you look at the ratio that the altitude divides the opposite side, so you can see here opposite side, let me take this altitude B. So opposite side means AC. So AC is divided like AE and CE, right? Or if you take this altitude AD, you can see the opposite side is BC. So you can see BC is divided as BD and DC, right? What is that ratio is what we need to see. See clearly BD is to DC equal to, okay, so we are talking about the opposite side, okay, from here it is from this vertex the altitude is dropped, okay, or the perpendicular. Now BD equal to DC, okay, the BD is to DC equal to tan of this, see BD is here, so this is to DC is here, so this opposite, okay, so I am talking about BD, so I'll take this is BD, so opposite to BD, that is angle C, so I take tan of that, tan C, okay, is to, when I talk about DC, so this is DC, so I'll talk about this angle is to tan B. I hope you understood, right? So altitude divide the opposite side in this ratio, BD is to DC. So it can be anything, it is not necessarily B, D, C, etc., right? So depends on the question, you can understand, right? So let me take this side, okay, this side, okay, like this side is what I'm taking. So this is the point where altitude becoming perpendicular, okay, so this is where the perpendicular, so this is the division. So if it is B, D, C, okay, so BD is to DC, that's what we have written here, is equal to this angle, tan of this angle and tan of this angle. Same way you can find this also, right? See, these results are going to be useful in some questions. Directly you can get some sides, okay? So let's take the second one, CE. And in fact, based on this facts only, you are going to get this equation, but I'm not trying to derive that equation. I'll be talking about the facts and then it's up to you, okay? So ultimately what I'm going to do is, see, I will develop the relations, okay, and I'll try to find out this point, okay? I'll try to find, see, once we know this is divided in such a ratio, okay, we understood this ratio, that is tan C and tan B. So we already know the ratio, this is tan C and tan B. So, okay, so there's a point which divides the line segment BD in the ratio tan C tan B. Once you know the ratio, you can use the section formula because you know the coordinates. So you can get this point D. Now you got this line AD, okay, now you got this line AD. Then if you know this point, that is the orthocenter. The orthocenter divide altitude in what ratio? So this is your orthocenter, in what ratio is divided? You can calculate this point again by using section formula. So that's what my objective. So I am just talking about the ratio here. After that you need to do that, okay? So first I tell you the altitude divide the opposite side in what ratio. That's what we have discussed. So with that you can find D. I hope you understood. So the ratio is given tan C and tan B. So you can find B, or you can find this point D, okay? Or similarly CE and CE and AE. So CE is to AE. So CE is this. So which angle I should take? I should take angle A. So which is equal to tan A. Then AE is this. So I should take this angle, right? So which will be equal to tan C. Similarly, if you go with this BF, right? So BF, so if BF means I should take opposite angle. So that is going to be tan A. Okay. Then AF, right? So BF is to AF means FA, which is equal to, I should talk about this angle, right? So that is going to be tan B. So you got the ratio in which the altitude divide the opposite side. Any one of this is enough for you guys. Any one of this is enough. You can either take this or this or this. Find that particular point, okay? Either D or E or F. Second, what we need is, I want to talk of this case also. The orthocenter divide the altitude in what ratio? Okay, so here orthocenter is this. So let me mark it as O. This AO, right? So this one and this one, AO and OD, what will be that ratio? See, you can see here, AO is to OD will be what ratio? That is what you need to find out, right? So from A it is dropped. We need to find AO to OD. So D is in which side? This side, BC, right? So take this one equal to tan B plus tan C. Okay, so that is your AO. That is this length is to, now that is your AO, the ratio, okay, is to, now from where you drop that, okay, that is from A, so is to tan A. Like that you need to do everything, right? So I am talking about AO is to OD. That means I am talking about this AD altitude. AD means I dropped from A to D. So D is on what side? BC. So take that two angles. That is tan B, tan C is to, from where? A. So tan A is to tan A. Okay. Now similarly, you can get BO is to OE. So BO and OE means B is here, O is here. So this is what? This is what the altitude I am talking about. That is drop to A and C, right? So obviously tan A plus tan C, tan A plus tan C is to from B. So that will be tan B. Similarly, when you talk about CO is to OF, which will be equal to tan A plus tan B is to tan C. So these ratio you need to remember, guys. Not only for getting the equation of the orthocenter, because equation of orthocenter anyway you are going to learn. That I tell you, that is easy only. Okay, otherwise if you get some questions directly, you can apply this relation and you can solve it faster. That's the use of this relation. And there is nothing to remember, there is nothing to mug up, you can just relate it, okay? So what I told you first is, this is what case? Altitude divide the opposite side in what ratio? Okay, so if you take this triangle, now how I am going to obtain the orthocenter coordinates? See, I am taking this altitude. Okay, so these are the three altitudes. Okay, this is your orthocenter. So I am taking the first altitude, that is AD. Now we know B, we know C, we know the coordinates of B and C. Okay, we understood this ratio also, tan B and this is tan C. Let me take this BC now. Okay, so let me take this BC. So BC, we know this is tan C and this is tan B. So altitude divide the side in this ratio, tan C and tan B. Once we know the ratio and once we know the coordinate, what you can get this point. So you got the coordinates of D. Now let me take this altitude AD. Okay, so what I'm going to do now is I'm taking this altitude AD. Okay, so in that my centroid is lying over here. Okay, so this is my centroid. Can I get it? I can get it because I know the ratio that orthocenter divide the altitude. That also we have seen, right? This is how, this is the ratio. This is the ratio. So I can get the answer, right? So when you do that, you will get the answer. See, if you know the answer of incenter, just a modification is what you are supposed to do, right? Incenter we know that is AX1 plus BX2 plus CX3 divided by A plus B plus C, right? Now in the same case, this is your X coordinate, X is equal to, similarly Y. So in the same case, what we need to do here to find X, instead of A, B, C, write tan. Okay, so tan A, tan B, tan C. So A, B, C become tan A, tan B, tan C. So this A become tan A, this B become tan B, the C become tan C, A become tan A, B become tan B, C become tan C. So that's your answer. Okay, so only one change. You understood incenter. So from that we also understood how to get all the three excenter. From that itself we also understood now how you're going to get the orthocenter. Just replace A, B, C as tan A, tan B, tan C. That's it. So what you will be getting, what is your x coordinate? That is your x tan A or x1 tan A plus x2 tan B plus x3 tan C divided by tan A plus tan B plus tan C. Similarly, y coordinate will be y1 tan A plus y2 tan B plus y3 tan C divided by tan A plus tan B plus tan C. Okay, so this is your orthocenter and this is the coordinates x and y. I hope this is clear for all of you. Now what is next? Next is your circumcenter. So like incenter, circumcenter is also important. Okay, so circumcenter is like this. Let's suppose you have a triangle. Okay, you have A, B, C. Coordinates of A we know x1, y1, B we know x2, y2, C we know x3, y3. So these are the coordinates. Now what we are going to do here is we are going to take the perpendicular bisectors of each. Okay, so perpendicular bisector means this is perpendicular bisector. It is bisecting. See here, this is perpendicular. At the same time it is bisecting. That means these two sides are equal. Okay, now here also I'll be taking that perpendicular bisector. So this is perpendicular, at the same time this is divided equally. Here also I'm going to do that. So this is divided equally and this is perpendicular. Okay, so I hope you understood what is circumcenter. Circumcenter is nothing but the intersection of perpendicular bisectors. Okay, see what was the problem with median or the centroid? Centroid means intersection of median. So when you're dropping the median, this is going to divide it equally. This is equal, but this is not perpendicular. Okay, what was the case with altitude? When you are taking the altitude, this is perpendicular, but this is not equal. Okay, so here what is the case? Here this is perpendicular and this is equal, but it will not touch the vertex. Okay, so it will go like this. See, this is the case. If you take this triangle, okay, when you drop the perpendicular bisector, it will go like this. It won't touch the vertex. So this is your perpendicular bisector. This divided equally. Now what is median? Median is this dividing equally, also coming from vertex. Okay, what is your altitude? Altitude is like this, not dividing equally, coming from vertex, but not dividing equally, but perpendicular. So three cases. This is altitude, this is median, and this is perpendicular bisector. Okay, so keep in mind, perpendicular bisector is perpendicular and bisecting, but not passing through vertex. Median is coming from vertex and bisecting, but not perpendicular. Altitude is perpendicular and coming from vertex, but not dividing equally. Okay, so see three conditions if you write coming from vertex, one case. Okay, then perpendicular, other case, then bisect. These are the three conditions if you consider. Now you can understand clearly what is median. Median is coming from vertex, but it is not necessarily perpendicular. It can be perpendicular some cases. It is bisecting. What is altitude? Altitude is coming from vertex. It is perpendicular, but it is not necessarily bisecting. What about perpendicular bisector? That is not necessarily coming from vertex. It is perpendicular. It is bisecting. So this is what the difference, guys. Okay, I hope you understood this clearly. So here I am talking about perpendicular bisector. And another definition of this very circumcenter is, see, you can draw a circle like this. Okay, so the circle is drawn, which is touching all the three vertices or all the three vertices of the triangle, and the center of the circle. The center of the circle is your circumcenter. Okay, so this is known as circumradius, which is understood or denoted as capital R. In case of in radius, it was small r, and we know how to find it, right? Now what we need is equation, right? So let me give you directly equation of circumcenter. So what we need is the x coordinate and the y coordinate. So see, again it is related to the incenter that we have learned. So see, centroid, no problem with the equation, that is x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. Incenter, ax1 plus by1 plus c or x2 plus c x3 divided by a plus b plus c, and ay1 plus by2 plus cy3 divided by a plus b plus c. So this is your incenter. In case of excenter, what we have done, in the first opposite to a, we will make a as negative. Okay, in x and in y, we make a as negative. Opposite to b, we will make b negative. Opposite to c, we make c negative. That's what excenter. Then we have seen orthocenter. Instead of a, b, c, we put tan. So what was that? x1 tan a plus x2 tan b plus x3 tan c divided by tan a plus tan b plus tan c. Similarly, y coordinate also you can write it. Okay, now here what I'm going to do is, in the very same incenter expression, this a b c I'm again going to change. Here I change to tan a. In this case I am going to change it to sine, not just sine a, sine b, sine c. I am changing it to sine 2a, sine 2b, sine 2c. Okay, so this is going to be, my circumcenter is going to be x1. Obviously now this is same, just replacing instead of tan a, sine 2a. Okay, so sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. Similarly, y coordinate, y1 sine 2a, this is y, this is x, okay, plus y2 sine 2b plus y3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. So this is your x coordinate and y coordinate, and this is your circumcenter. Okay, so I hope you understood all the 5 centers that we have discussed. We started with centroid, then incenter, then we discussed about 3 excenter, then orthocenter, then circumcenter. Okay, now one important result that you can remember is centroid and incenter is always inside the circle, is always inside the triangle. Okay, always inside. Excenter is always outside. So you don't want to have any confusion with respect to these 3 centers. But what about orthocenter and circumcenter? See, orthocenter, it depends on the type of triangle. If it is acute triangle, like what we have seen when you drop the altitudes, okay, when you draw the altitudes, it comes here. So you can see inside. Inside in what case? Acute triangle. Now, in case of right triangle, what will happen? See, when you draw this, it will go like this. From here, it will go like this, and from here, it will go like this. So this is where. So where you are getting the 90-degree angle, that's where your orthocenter in case of right angle triangle. So where is the orthocenter in case of right angle triangle? At what point it is right angle? That's where you get the orthocenter. So if it is ABC, B is your orthocenter. So this is on the triangle. Now what if you have a obtuse triangle like this? Okay, see, when you have obtuse triangle, when you drop this, okay, so from this vertex, okay, and from this vertex, okay, and from here, what you'll get is somewhere here you'll get a meeting point. Okay, so basically I want to say that this is going to be outside. So 3 cases. In case of orthocenter, if it is acute triangle inside, right angle on the triangle, obtuse triangle outside. Same is the case with circumcenter also, guys. Okay, so circumcenter, if it is acute, we have already seen when you drop the perpendicular bisectors. So this is inside. So circumcenter is inside if it is acute. What if it is right angle? If it is right angle, what will happen? Okay, see, from the center you are dropping, right? So from here also you dropping. Okay, now you can see from here also it will go, right? So you are getting it on the triangle, and one important result that you need to know is this is actually on the hypotenuse, and this is a midpoint of the hypotenuse. Okay, so the center is at the midpoint of the hypotenuse. So when you draw the circle, it will touch all the 3 vertices, and we have solved this question in geometry, in fact. Okay, so if the hypotenuse, if I am giving it as 13, this is a midpoint, that is 6.5. okay, now what about obtuse triangle? Obtuse triangle, if you take okay, like this, it is going to be, okay, outside. So this is outside. So that's the point, guys. See, if it is acute triangle inside, if it is right angle on the triangle, if it is obtuse outside, similar to the orthocenter. But very important point that you need to note down here is, observe here this right angle, where the orthocenter in case of right angle, that is at the right angle, where the circumcenter in case of right angle, that is midpoint of the hypotenuse. That's the two important point that you need to note down. Second important point that I need to tell you is, in case of an equilateral triangle, you join all this thing, okay? So the centroid, the incenter, the orthocenter, and circumcenter, all the four, not excenter will be always outside, okay? So all centroid, incenter, orthocenter, and circumcenter, they all will coincide in case of equilateral triangle. So this is A, and this is A. So in case of equilateral triangle, all are same, okay? Now except for an equilateral triangle, the centroid of the triangle divide the segment joining circumcenter and orthocenter of that triangle in the ratio 1:2. See, you take any triangle like this, okay? This is not an equilateral triangle. So understand this as circumcenter, okay? So I mark it as C, okay? And this is let's say O, okay? So this is the line segment which is joining circumcenter and orthocenter, okay? Now what we are saying is, the centroid is here. Centroid divide the line segment joining circumcenter and orthocenter in what ratio? 2:1. So you can clearly say OG is to CG equal to 2:1. So on the side of orthocenter it is 2, guys, remember. On the side of circumcenter it is 1. So this is again a very, very important result. In case of equilateral triangle, all four centers coincide. If not equilateral triangle, I am talking about three centers, that is circumcenter, centroid, orthocenter, not incenter is coming here. Now the line joining circumcenter and orthocenter is divided in this ratio 1:2 by the centroid. Okay, so I hope you understood. There is no need to have any doubt. If you have any doubt, get back to me. This is my number. Okay, so see you guys.